Hello fellow YouTubers, this is N0AGI. I'm here to talk about an application I'm writing in a .NET programming language to programmatically control, to turn this radio on and off based on the satellite pass-through through my area. And what I use for visual purposes is this tool called the Simple Sat. I'm sure many of us know this tool written by W9KE Tom Doyle. He's done a phenomenal job at this tool. It gives me a good, and of course the rest of the ham user community, a very good visual of when a satellite pass-through occurs. It tells you some prediction data as to when it's going to occur, what the duration is, and what the maximum elevation is for that pass-through. As you can tell from here, I just had a pass-through not too long ago by ISS, and the next pass-through is in about an hour and 20 minutes. That'll last for about 8 minutes with a maximum elevation of 23.4. What I'm really trying to do is to apply this idea of extracting the prediction data from the NASA provided TLE and then programmatically turning on the radio based on the pass-through date and time, and also make some decisions on whether to turn on the radio based on how much the maximum elevation is for that particular pass-through. That's going to provide me the ability to programmatically control whether to turn this radio on or off, and thereby saving some power consumption. So let's get started.
So what I have here is a screen of the first screen of the application, and I'll do a quick walkthrough of the app here. The top section here lists all the satellites that I care about, and this list is derived from an XML file that I can modify, edit, or add to. Basically, what I will identify in that list or XML is the satellite's official name, the URL where I can find its tool line element data from, or TLE data from. This data is published by NASA, and the TLE for this satellite is published in this URL. And whether the satellite line item is enabled for this application or not, and when was it last refreshed, as in when was it last obtained from this URL, and how many days old that data is. Likewise, I have the ISS, the PSAT, and PCSAT. As you can tell, the first two line items are enabled while the last one is disabled, which means that the application does not process this last line item for PCSAT. This section here, the predict data section, talks about the detail for each of these satellite line items. So when I select that, this grid gets populated with its details, that is, and one of the properties of this satellite line item is the predict data, and it's a collection of predict line items that were determined for International Space Station based on the two-line element data we secured from the NASA published data file. Now when I go into the collection here, it shows a list of prediction line items for ISS. Now the first one, there are a total of 8 here, but there could be more. And there are 8 here. The first line item says the acquisition of site elevation is at about 70.2. The acquisition of site time is 5:25 p.m. Today. The horizon time is 5:19 p.m. and that this prediction line item is enabled. Now, what I'd like to draw your attention to is this item here, or this property here called AOS-EL, or the acquisition of site elevation. Now, the reason why this property here called is enabled is set to true is because I have a property, I have an option in the application called um, minimum AOS elevation to intercept. And what that tells the application is intercept all pass-throughs that have at least a 10-degree of elevation based on the prediction data. In this case, the elevation is 70.2, which is above the 10 degrees that I had requested for, and hence the prediction is enabled, which means that this line item is a qualified prediction pass-through based on the settings I chose here. The second line item, as you can tell, the elevation is 9.4, which is below the 10-degree elevation I'd asked for, and hence it's disabled. Now, what this means is, if it's disabled, you could it still lists as a prediction line item, or the pass-through line item, but the application does not automatically work the radio when that pass-through occurs. So the default in this case is false. Obviously, you could change that to true and have it force to work the radio, so that even though the elevation is 9.4, the radio will be turned on at the horizon time, the 6:56 p.m. time, and then will be turned off at the LOS time. So that's the collection of prediction data that the application determined based on the two-line element. On the note of prediction data and the logic behind predicting pass-throughs, as you can imagine, there's a process flow. There's a lot of there is a quite a bit of logic and formulas involved, a lot of mathematical formulas involved to determine the pass-throughs for each of these satellites. So rather than me reinventing the wheel, what I had done is I had taken advantage of an application that Michael Henry wrote, and that application can be acquired from this URL. The application is a command line tool. It's called aospro.exe. You should be able to download the application from here. Basically, the way the app works is you supply the TLE data that I gathered from here, and then supply the required longitude, latitude data, and supply it with the date and time command line parameters, and the application, the command line tool, will spit out the prediction data for that particular satellite's pass-throughs. It's a pretty cool tool. Many thanks to Michael. The tool is immensely valuable and useful. I also use the other tool made by Tom Doyle, W9KE, which basically provides a visual of the satellite pass-throughs. I use this quite a bit in my International Space Station pass-through operations. It basically gives you the date, the time, the length of pass-through, the elevation, etc. The tool is a very simple to use, easy to set up tool, and I definitely request that you download it and take a look at it. So what I'm really trying to do is merge or adopt some of this idea into my application, and then make it so that it not only predicts the pass-throughs, but also using the pass-through data, it turns on or off your radio that works the ISS or PSAT or PCSAT or whatever be the case. So that's the point about the predicted data. If you look into these the URLs, the TLE source, when I click on it, you can tell this is these are the two-line elements data for each of the satellites. As you can tell, there's quite a few satellites listed in this file. I only care about the ISS for this particular application. So what I do is when I create the XML file, I identify the URL, give it the official name. It's important to identify the official name because NASA uses the official name to list down the two-line element. So the application does a compare match to this data file and pulls out these two line items for that satellite. So that's the predict data. What this provides here, called the top pass-throughs, is it provides a list of pass-throughs for each of the satellites. And the pass-throughs that are listed here are the next occurring pass-through that matches your filter, which is the filter for, hey, the minimum AOS elevation filter. In this case, I chose 10, so it pulled up from this list here that we looked at earlier. It pulled up the first one, which is the 70.2 degree elevation pass-through, which will occur in a few minutes, or in a few minutes here actually today. And the second is of course for the PSAT, which will occur later today, or tonight actually, at 11:15 p.m. Central. Um, on the far right here are the options for the application. Never mind the names of these options. These are not as user friendly as you can tell. These are more developer friendly names of property names. Um, but with that aside, I would like to walk through quickly what each of these options mean to the application. I will save this for the last, but let me start with audio alert. What that does is when there's a pass through, the radio or the logic that turns on the radio, when that logic kicks in, it announces an audio alert, and likewise when it turns itself off, there's an audio alert. There is also an early start offset, which I'm going to remove in the next build. Basically, what we are trying to do is say, hey, start 2 minutes before the pass-through occurs, or 2 minutes after, or whatever be the case. But in this case, I will not need that property or option because I'm basing things on horizon time, or optionally AOS time. Horizon time starts before the AOS time occurs, so this option is really a redundant option. Enable operator on startup is when uh, this option controls this checkbox here. When this box is checked, the application turns on the logic that controls the working of the radio. So when there is a pass-through, and when this option, when this checkbox is checked, it automatically turns on the logic that turns your radio on or off. If you were to uncheck this, it basically depends on you to either enable the pass-through or disable the pass-through. For now, we'll leave it on. And when you leave it on, the spinning wheel turns just to indicate that there is the logic is working. The next option is we already looked at this one here, so we won't cover that, but latitude and longitude is my QTH location, which is required for determining the prediction data for your location. The next option is target auto refresh after each pass through. What this provides is after a pass through occurs, the application can be configured to go to each of these locations and refresh its TLE data so that the data becomes the most up to date. There is also auto refresh on startup. What that does is when you start the application, it goes and finds the latest TLE data from these locations for those satellites. This last option here says, hey, use the AOS time instead of the horizon time. if you look at the prediction data, really each prediction data has three distinct times. The first one is the horizon time, which occurs before the acquisition of sight time, at least 5 minutes or so. And then the AOS time occurs, and then it ends with an LOS time. So what we are saying is work the radio based on the horizon time and not the AOS time. I mean, you could choose to do that by simply turning this on by double clicking on it to make it to true or false. But the advantage of having a horizon time is that radio is turned on 5 minutes prior to the actual acquisition of sight of your satellite. So that's that option. Let's talk about this first option before we close. The Add Debug Pass-Through option allows for the application to create a pseudo or a fake pass-through line item. And what that provides is, let me double click that and force a TLE. As you can tell, it added this dummy fake test set line item. And what that provides is an option for you to test the pass-throughs. And this allows for you to do things like, hey, is my logic working to turn on the radio and turn off the radio? Sort of a debug option. You can leave it on and do some tests while you wait for the other passes to happen. This is purely for testing purposes only at this point in time. Okay, so let's talk about this test, the debug pass-through test. When you turn it on, it creates a test, the fake test record or the fake test line item with 2 minutes out horizon time at a 2-minute duration. And then when the clock meets that horizon time, it automatically turns itself or turns the logic on to turn the radio on. And then when it hits the LOS time, it turns off the radio logic. So basically, it's a good, nice tool to have when you're debugging or testing your radio setup, etc. If you had to install a dummy load or whatever be it, you could try this out to make sure your setup is working. Um, so that's that. And the far right section here, I think we briefly covered. Right now, the radio logic is turned off. When there's a pass through, it automatically turns on and turns the color to red. The bottom, like you see here, right now the time is 5:01. The horizon time for this test record is 5:01, and it'll remain on till the LOS time passes through. Now it's in red color just to indicate that you're on air. And then when the LOS passes through, it turns itself off. The bottom section here is a dump of the debug messages from the application. Uh, Really, the sole purpose of this is to help debug any issues uh, in the application and hopefully resolve those issues. You could either read the log file here in this window, or you could open the log file in your notepad or whatever be your editor. And as you can tell, the log file is fairly detailed. It's categorized per satellite, per module within the application, so you can very easily identify the issues and try to debug and resolve those issues. So that's the quick look at the application. Let me disable this operator for now, and let me pull up Visual Studio and show you some source code um, behind the application. This one is the XML file I was telling you about. Basically, you can edit this XML file, insert your own satellite data, and the application will read this file at startup and then pull the TLE information from those source files. Make sure your friendly name is whatever name you prefer, but make sure the name is the official name that NASA uses for each of the TLE files. And if you want it enabled, make sure you turn it on. Otherwise, you can turn it off by simply saying false. So that's the XML file, and there's a bunch of other C# files I'm working on. Um, so as an example, if you look at a TLE target, the application I call a TLE target a satellite, a TLE target. So it could be ISS, PSS, or PSAT or PCSAT or whatever be the case. Each of the TLE target has these properties, and then each of these TLE targets has the prediction data attached to this and so forth. So the predict data has the horizon date, time, blah, blah, blah. And then there is a utility class to provide some utility functions. And the working memory is a simple forward chaining AI, basic AI for determining when to operate the radio versus not, sort of a logic. So that's pretty much it. Thanks for watching. What I'd like to request is if you're interested in testing this application as a beta user, I would greatly appreciate it. Please do visit N0AGI.com and go to the satellite TLE prediction operator or STPO link in that page, and you should be able to download the application. Please note, however, that the application again is in beta stage, so that you should expect to see some bugs as you test it out. Also note that the current build does not have the logic to turn the actual relay, the hardware, on or off. The logic behind turning the circuitry on and off is already in the tool, but the actual working of the hardware to turn the relay module on or off is not in the tool yet. Um, Obviously, that would take a little bit extra additional work that I'm working on right now in parallel. I have the circuit board ready. Basically, it's a relay box that's connected to your radio, and you essentially turn on the relay using a USB relay carrier board, and then the relay would in turn turn itself on and then turn on the radio when the pass-through occurs versus not. So please keep that in mind as you sign up for. Actually, there's no sign up process. You can basically download and just let me know what you think. Would love to hear your feedback, any comments, ideas. I'll do my best to implement as many ideas as I can, but I cannot promise that I will be able to install every or implement every feature that's requested for. So in any case, thank you so much for your help and thanks for watching. We'll talk soon.